Well, now that you have the basics of balancing equations and counting atoms within molecules and reading the periodic table, figuring out the products based on the types of reactions we have, then we're going to use all that information to help us determine exactly how much we need or will produce in a reaction. We call this process stoichiometry. Stoichiometry is a type of calculation that uses balanced chemical equations, the mole, and molar mass to determine how many grams or moles of a substance gets reacted or is produced. It sounds super complicated, but it's really not. For example, if you wanted to run a chemical reaction that makes exactly 10 grams of a substance, you could either A, throw the reactants all together in a trial and error kind of fashion and see if you can figure out how to get 10 grams out, or B, do a little bit of math first, and then you know exactly what you need in order to produce what you want. As an old carpenter once said, it's better to measure twice and cut once than to measure once and screw it all up. Remember, if we have a mole of a substance, that means we have 6.022 times 10 to the 23rd particles. If we had the urge to, we could calculate how many particles we use, but we don't need to. Scientists created the concept of the mole so they could work in smaller numbers, at least numbers that don't have 23 zeros at the end of them. When looking at a chemical equation, we've learned that the coefficients tell us how many molecules or particles of a substance we use or produce in that reaction. We can directly translate that to moles. So instead of saying I combine 2 molecules of H2 with 1 molecule of O2 to create 2 molecules of H2O, you could say for every 2 moles of H2 and 1 mole of O2 that are combined, I create 2 moles of H2O. So how do we find out how many moles are being made or being used? Well, that's easy peasy. You simply look at your equation and do some quick math if necessary. So if my equation says that for every 2 moles of H2 and 1 mole of O2, we get 2 moles of H2O, then if I completely react 4 moles of H2, I'll need at least 2 moles of O2 to react. And then I would produce 4 moles of H2O. Or if I wanted to create a half a mole of H2O, I would need a half a mole of H2 and a fourth of a mole of O2. The balanced chemical equation is a lot like a recipe. It tells you what you need, how much of each thing that you need, and how much you'll get out in the end. If we want to make half as much, then we just divide all of our coefficients by 2, and that tells us how many moles we needed. If we want to make twice as many cookies, then we multiply ingredients by 2, and we get twice as many cookies out. So what is molar mass? Molar mass can help us to convert from moles to grams or from grams to moles. You can't count how many particles you have, but you can measure its mass. If you convert the mass to moles, then you know how many particles you have. And that is a ratio of how much mass is in 1 mole of a substance, and the units are always in grams per mole. To calculate the molar mass of a substance, we have to use the periodic table. The atomic mass that we find on the periodic table directly relates to how many grams we find in a mole of that element. So to find the molar mass, we simply take 1 mole of our substance and count up all of the masses. This takes us back to counting atoms in a molecule again. For example, if I have 1 mole of H2O2, then I have 2 moles of hydrogen and 2 moles of oxygen. Hydrogen weighs 1 gram per mole, and oxygen weighs 16 grams per mole. Therefore, I'd have 1 plus 1 plus 16 plus 16 grams, giving us 34 grams for every mole of H2O2. To convert between moles and grams, all you have to do is multiply or divide. If you're going from moles to grams, then you multiply by the molar mass. And if you start with grams and want to convert it to moles, you divide by the molar mass. For example, if I had 2 moles of my H2O2, I'd multiply my 2 moles by 34 grams per mole to find out that I have 68 grams of H2O2. We can use the balanced chemical equation to convert from the amount of one substance to the amount of another substance. And we have to go through the moles in that process. We can't go directly from grams to grams. So if I use my previous equation, say I had 4 grams of H2 to start with, to convert from grams to moles, we need to divide by the molar mass of H2, which is 2 grams per mole. This tells us now that we have 2 moles of H2. If I want to know how many grams of oxygen we need, then I have to go from moles of H2 to moles of oxygen. So if we have 2 moles of H2, then we need 1 mole of O2. Now we multiply by the molar mass of O2, which is 32 grams per mole. We find out that we need 32 grams of oxygen to react with our 4 grams of hydrogen. So let's do a quick practice problem that relates to the real world. On the International Space Station, we have astronauts living up there, and they exhale CO2. Well, we have to get rid of that CO2 somehow and turn it into something useful. If we react CO2 with 2 moles of lithium hydroxide, it turns it into lithium carbonate and water. So if I knew that the astronauts on average exhale 20 moles of CO2 daily, I want to find out how many grams of H2O are produced. So the first thing we do is write down what we're looking for. We also write down what we know. We know that there are 20 moles of CO2. And then we'll figure out what we need from there. So to start off, I use what we know. That's the first thing. We know there's 20 moles of CO2. And to get from moles of CO2 to moles of water, we have to put a ratio based on our equation. So for every 1 mole of CO2, we get 1 mole of H2O. That helps us to cancel this unit out, and we're one step closer to grams of H2O. To get 2 grams of H2O from moles, we have to multiply by the molar mass. First, we have to find the molar mass of H2O. So to find the molar mass, we write down how many atoms in our molecule we have. There are 2 H's and 1 O. H weighs 1 and O weighs 16. So we get 2 plus 16 is 18 total grams per mole. So now, like I said, we multiply by our molar mass, 18 grams of H2O, and every 1 mole of H2O. That crosses out our moles of H2O, and we get 20 times 18, which is about 360 grams of H2O being produced in this reaction daily.